Hello class, this is lesson 8-7 in our textbook titled How to Factor Special Products. We've done a lot of factoring already. Some of them were pretty difficult, but this lesson's really easy. There's just some very special cases that follow a specific rule. The first case is if you're given a polynomial that's some number squared minus something else being squared, it can just be rewritten as a plus b times a minus b. So whatever the first term is that's being squared goes right there. Whatever the second term is that's being squared would go as the b. So let me show you an example. Right here I have y squared minus 16. And at the very beginning I can see, oh, well that first term, that a, is just y times y, which would be the y squared. Minus, how do I get 16? Well, that's the same as 4 squared. So really, when I'm factoring this, I can write it as y plus 4 times y minus 4. Because this y right here is the a, and this right here is the b. Awesome. Let's move on to our next example. It says 25m squared minus 36. So this time, trying to think what is being squared in the beginning minus what is being squared at the end. So 25, if I square 5, I'm going to get 25. And if I square m, I'll get 25m squared. Minus, that's just the number 6 being squared. So I can put this together by following the rule at the top. 5m plus 6 times 5m minus 6. And that would be my answer. Sweet. Let's do one more. This one is 12 minus 48m squared. And already I'm thinking, that's not a perfect square, and 48's not a perfect square. So what you can do when you have an instance like this is always, let's just try to see if we can pull some number out. And I can take 12 out of the whole polynomial. So if I divide 12 divided by 12, I'm left with 1 minus 48 divided by 12 leaves me with 4m squared. So now I'm going to pretend that the 12 is not even there, and I'm going to try to see, does this relate to that rule up above? Is it something being squared right here minus something else being squared? Yes, it is. So I'm just going to leave that 12 on the outside. That's the same as 1 squared minus 2m being squared. So if I'm going to finish this off by writing it just like the rule, that's the same as 12 times, in parentheses, 1 plus 2m times 1 minus 2m. And I'm done. All right. I have one more rule for you, so let's go ahead and look at that one. This one is actually a two-parter. You can have a polynomial of the form a squared plus 2ab plus b squared and factor it out so it's just a plus b, in parentheses, being squared. Or it can look almost the same except it's going to be subtracting the second term. And in that case, it's going to be a minus b being squared. So let me walk you through this. Here's our first example. It says n squared minus 12n plus 36. So when I'm writing this out, I want to think, okay, what is being squared at the beginning? Oh, it's just n being squared. Minus, and let's go back to our format. Since it's a minus, I'm going to go to the second one. 2 times whatever the first term is times the second term. So that's the same as 2 times n times, let's see, if I want to make that 12n, this has to be multiplied by 6 because 2 times 6 would be 12. Plus, does this match with the n, 36? Would that be 6 squared? Yes, it is. So I have my first term right here. My second term, this would be the a and this is the b. So all I have to do is rewrite it as, in parentheses, n minus 6 and square that whole thing. Pretty awesome, right? Easy factoring. So here's our next one. It says 9x squared minus 12x plus 4. So this time I'm going to do something a little different. I'm going to just look to see what is being squared here to turn into 9x squared, and what's being squared at the end to turn it into 4. So 9x squared, that's the same as 3x times 3x. And the n, I get 4 by squaring number 2. So now, this is why I really, really like this. This is going to be subtracting 2 times this first term, 3x, times the last term, 2. And let's just double check. 2 times 3 is 6. 6 times 2 is 12. And that gives me my negative 2x, or 12x, I'm sorry. So in parentheses, it would be my first term, the 3x, minus the last term, which is the 2 squared, and I'm done. All right, I have one more example for you, and then we're actually done with our lesson for today. So this one starts with negative 3y squared plus 36y minus 108. And it's kind of similar to the problem over on this side where I'm not starting with a perfect square. So let's go ahead and let's pull that out, the negative 3, out of everything. So when I do that, I'm left with y squared minus 12y, because negative 3 times negative 12y gives me positive 36y, and then plus 36, because negative 3 times positive 36 gives me negative 108. And now I can go back to that rule up above. This matches with the second one. So it's negative 3 times y squared. And over here, this is going to be plus 6 squared. So that means in the middle, it's going to be minus 2 times y times 6. And that's negative 12. That matches perfectly up above. So awesome, it works out. This is going to be y minus 6 being squared with the negative 3 right in front. And that's all that we're learning today. So learn those rules. I'm going to give you 3 practice problems for you to do on your own. The number one is 4y squared minus 64. The second one is 2y squared minus 20y plus 50. And the third one is negative 2x squared minus 16x minus 32. So come with these complete when you come to class, and we'll discuss more about it when I see you then. Bye.